asking about this one. So Casey wants to plant a raised triangular garden. She maps out the garden using the coordinates in cubic feet labeled ART, so triangle ART, as shown in the picture. Note that the line DT represents the height of the triangle with the base AR. Okay, so determine how much wood she would need to go around the perimeter of the garden. So we're going to find the distance for these three sides. Okay, just a reminder, your distance formula is this guy. Okay, so you should probably write that down on your paper if you don't already have it down. When you are solving for these things, what I would suggest is go ahead and write out the point. Okay, so like this is 1, 2, 3, 4, 5, 6, 7, 8, comma 4. Okay, and this one is 1, 2, 3, 4, comma 2. So if they don't already have it listed, I would go ahead and write them out. And then decide which line that you're going to start with. So I'm going to do AT. So AT. And I'm going to plug in X1, Y1, and X2, Y2. And I'm going to plug all that junk in. So we're going to get 4 minus 6 squared plus 8 minus 0 squared. And I'm going to type that into my calculator. So square root of 4 minus 6 squared plus 8 minus 0 squared. And that's going to give me 2 square root of 17. Okay, so this guy's got a distance of 2 square root of 17. All right, we're still not done. We have to do AR. And AR, we're going to put that, I'm going to put it over here. Not really, I don't have a whole lot of space. So this is going to be my X1, Y1. This is going to be my X2, Y2. I'm going to plug in. And so that's going to give me 4 minus 0 squared plus 2 minus 6 squared. I'm going to plug that into my calculator. So square root of 4 squared plus 4 squared. So that's going to be 4 root 2. So AR is going to be 4 root 2. And then RT. Okay, again, it doesn't matter which one you label X1, Y1. Okay, so RT, we're going to get the square root of 4 minus 8 squared plus 2 minus 4 squared. And I'm going to type that in. Squared plus. And that's going to give me 2 square root of 5. Okay, so we got 2 square root of 17, 4 square root of 2, and 2 square root of 5. So we're going to add all that up. So 2 square root of 5, 4 square root of 2, plus 2 square root of 17. Okay, now sometimes the question might be written out where it wants it in radical form. And then sometimes it might want it in decimal form. Okay, so with that being said, if you added all that together, you would get 18.837 or 38, depending on how you round. Are there any questions about that? You need to make sure that you put units on there, so it should be feet, right? Now, we needed to determine how many cubic feet of mulch she's going to need to cover the inside of the garden. So this is talking about area. Area is 1/2 base times height. Up here at the top, it said that DT is the height with the base of AR. So now we've got to figure out the distance between D to T. So this line right here, because that is your height. Okay, so we're going to find the distance. And this right here is 1, 2, 3, 4, 5, 5, comma 1. We're going to find the distance of DT by plugging it in. And that's going to give me 8 minus 5 squared plus 4 minus 1 squared. And when I type that into my calculator, I'm going to get 3 square root of 2. Okay. So we've got 3 square root of 2, 1/2 times 3 square root of 2 times our base, which is AR, and that's 4 square root of 2. When I plug that into my calculator, I'm going to get a syntax error because I didn't type it in right. I'm going to get 12. And I get 12 cubic feet. okay, because that's what it's measured at. Now, what type of triangle do we have? What type of triangle do we have? So are all the sides the same length? No. Are two of the sides the same length? No. So this is called a scalene triangle. So this is your triangle that you're working with. Now, fortunately, whenever you have a vertical and a horizontal line, you can actually just count the spots. So we've got 1, 2, 3, 4. We didn't have to do the distance formula on this one because we can just count it visually, right? Now, for E to F, we're going to use the distance formula. And so when we plug in, we got E, which is 0 to 2, and that F, 4 to 0. Let's plug in 4 minus 0 squared plus 0 minus 2 squared. When we plug that into our calculator, we're going to get square root of 20. And then when you plug in B to F, that's also going to give you the square root of 20. Okay, I'm just telling you that right now. Now you can sit there and you can actually plug that in. That's fine, but we're just going to leave it as is. Now, what do we already know about this triangle? Is it an isosceles, a scalene, or an equilateral? It has two sides that are the same. Isosceles, okay? You need to know that one. Okay, that always just pops up randomly. Now, when you add these together, plus square root. Love a good calculator. So good. All right, so that's going to give us 4 square root of 5 plus 4. If you did the decimal form, then it should be 12.94. Okay. What is the area of the triangle? Remember, this is 1/2 base times height. If you have a triangle and it's turned sideways, you almost want to think like if you turned it upright, where would the base be? And the base is down here. The height is right here. The base is 4, and the height just happens to be 4. So we get 1/2 times 4 times 4, and that's going to give me 8. All right. So let's go ahead and chat. Here you go, babe. So what? Okay. So when you graph it, you should get this. Okay. And then your side lengths, this top one should be 1, 2, 3, 4, 5. This should be 5. And then what did you get for the distances on the sides? What did you get for the distances on the sides? What did you get the distance for the side lengths? Like AB to DC, what'd you get? Anybody do it? Same. You got 3? Okay, so let's take a look at it. All right, so from A to B, we are taking these points. We're going to label them X1, Y1, and X2, Y2, and we're going to plug it in. So I'm going to do that right here. So that's going to give me -1 minus -3 squared plus 2 minus -1 squared. When we plug that in, because it's a minus and negative, the distance formula already has a negative in there. So minus a negative would make that positive. Mm-hmm. So it's already negative because it's possible. If you're subtracting it, yeah. Yeah. Okay, so I can make sure I didn't do that wrong. Okay, so you should get the square root of 13 is what I got. Okay, so that means that this side length is the square root of 13 and this side length is the square root of 13. For perimeter, you're going to add up all the sides. You're going to do square root of 13 plus square root of 13 plus 5 plus 5. And so that'll be 10 square root, 10 plus square root, 10 plus 2 square root of 13. Okay. Now area, this is the new part. You learned area of quadrilaterals as base times height. That's how you learned it. When you look at the parallelogram, when you want to talk about the height, it is from the bottom to the top. So that's 1, 2, 3. So it has a height of 3. The base is the bottom, which is 5. So what is 5 times 3? Okay. What type of quadrilateral do we have? You got a list of them yesterday. This is called a parallelogram. And that's because these angles are not 90-degree angles. You have opposite sides or parallel. And we can confirm that, but they only asked us to do these two things. Okay. All right. So what were the side lengths on this one? What are the side lengths on this one? Like, what's the short side? Okay, what's the long side? Unknown. So again? 8.25. Okay, square root of 72. Everybody get that? So we're just gonna go with it. Only one person in this room did this problem? I'm not saying it's right, wrong, and different. Okay, we're going with square root of 73. What'd you get for the side length? Square root of 13. Okay, now what type of parallelogram is created by this 10? How do we know? We only got like 4 options. We got a square. Is that a square? No, why not? Okay, all sides aren't equal. Okay, we've got a rhombus. Does that look like a rhombus? No. We've got a parallelogram. Could be. Or we've got a rectangle. Okay, did anybody confirm that the opposite sides are congruent? Wow. Thanks, guys. All right. So what does it look like just kind of right off the bat? What does it look like? Maybe a parallelogram. If you turn your head to the side and kind of squint a little bit, or better yet, if I get rid of that, what does that really look like? Kind of looks like a rectangle. How would we know? How could we tell the difference? Could we find the slopes? Yeah. You could find the slopes of each one of these and determine what? The slopes make perpendicular, then they're rectangles, right? Okay. All right. So now that it's been dead quiet in here and you haven't been paying attention, let's try, take out your laptop and you're going to go to this Desmos activity to work on parallel, perpendicular, and neither. Okay, so this will be on your test. Okay, so please make sure that you get a little bit of practice. We haven't seen this in a while, but we want to make sure that we're good to go on this. So go ahead and log in.